But we second to put up. Oh, world. It's going to be a quick stream tonight. I always try to get these done sooner than later, but it never works out as such. That's okay. I made some progress today. Had a little idea formulation session yesterday or last night, where I was speaking about taking a webcam such as this that you see me in right here at the bottom of the screen, and actually mapping that in game as isometric tiles. In this case, it's supposed to be cubes, but that's okay. Got a wee demo working. We're going to look through some of the code, how that works, and then I'll go ahead and show the feature. So we'll hop right into it. For anyone listening on YouTube, your comments will be read directly into the chat and into my headphones. So thank goodness it's Friday. There's going to be a street painting festival here. It's kind of a highlight of South Florida life. And I've missed most of them the last couple of years, but when I first moved to America, that was the town I lived in. So looking forward to that. Give myself a wee second to get hydrated and then we'll get on with it. And I expect to be on for maybe 15 minutes tonight, and it'll be a quick one, but packed full of info. Hopefully interesting. Cheers to that, guys. So just some awareness in my setup here. This is streaming using Kinto in combination with OBS. And I have a vertical stream going into YouTube. I have a horizontal or desktop stream going into Twitch. And more importantly, I have a recording saving locally on my disk, which I'll be able to edit into a little video series. And I have at least one part of that completed. So we're just going to hop directly into it. All right. So what am I talking about? Well, let's first talk about what a 2D game is, or what a pixel is, or what a tile is. Think of a square, something like this. Let's see. I've already lost my little pen or canvas. Nope, got that. All right. So typically in a 2D game, you'll see them either compose, sideways, be top down. There's a bunch of different definitions. Pretend this is a square. When we're dealing with isometric, we're dealing with more of a rhombus shape, something like that. Essentially what we're doing there is applying a simulated 45-degree rotation, and we accomplish that with some basic maths, basically taking the width and then dividing that by 2 to get our height and changing the positioning, and that gives us some results. All right. So we'll clear that up and we will hop right into it. Thank goodness it's almost Friday. Happy about that. Let's pull up some notes and we shall get going. Let's see what we got here. All right, folks. So today we're doing something pretty cool. We're turning a live webcam feed, just like the one you see here, into an isometric tile-based effect in real time. So the eventual goal here is to basically make the webcam an input source for the game. But we're just going to start simple and just start with the MVP, minimal viable product, basically demonstrate the idea. So if you've ever wondered how to transform video data into a grid of colorful isometric blocks, or in our case tiles tonight, stick around because I'll be breaking down the implementation here. Okay. So, Kinto here, we turn the tiles back to existence. So this is an isometric grid. It's just composed of tiles. Up here, 0, 0, 0, 1, blah, blah, blah. You have your rows and your columns. Doesn't matter which one you assign. For this instance, we'll call the left-hand axis right here columns. We'll call these rows. So we'll get rid of that again. A second here. It's way cleaner to have that invisible. All right. As noted before, these avatars are controlled by the live chat. And we will get into that in another video. This one is a specific specific video, we're going to be talking about an effect. So essentially what we're going to do is take my webcam feed that you see right here. We're going to process the image into a lower resolution to keep performance in check. You're going to see the performance is terrible. That's what I meant by MVP. It's basically just to demonstrate the idea works. Of course it does, but actually show it. We're working in the web browser tonight. We're working with JavaScript. We're working with React. We're working with Canvas specifically. And as the series progresses, we'll talk more about WebGL and some optimizations we can make here. So essentially, we're going to take each pixel that composes this little image that I'm in right here in the lower resolution canvas. And we're going to map the colors of each pixel to actual tiles. So like I just demonstrated a minute ago, how those kind of triangular or rhombus shaped tiles, we're going to use those to compose an image generated from pixels here. And to keep things simple, because my computer's chugging along here, we're just going to be using a 50 by 50 pixel representation of the webcam. So significantly not HD. That's okay. The tiles are going to be rendered in isometric space, so it kind of fits in with the rest of the game. I can go ahead and just quickly demonstrate what that looks like. Here's another textual representation of what I'm describing, a 2D representation of tiles. And when we apply an isometric effect, we get something that looks more like this. All right, so let me go ahead and reload my local here. So I have a local machine. It should be coming through on both displays. Go ahead and reload. All right, cool. I'm gonna get the game part of the world out of the way. We can pop that down there. Open up my inspector here and manually invoke this. It's going to request a media stream by passing in my webcam. And it's only updating at 1 frame per second. But as you can see, this is literally composed of tiles that are mapped from pixels. And we're obviously going to be working on the performance here. The first thing is just to get this put together. Because what we could do to make this interesting is we can start applying basic physics and stuff, like using a hand to swipe things out the way in the game, kind of like Pong or something like that, and actually make the webcam a physical input in the world. So that's the eventual goal there, but we're just starting with using it as an effect. All right, carrying on. I'm going to continue to describe this. I don't want to ramble on too much about my leaking toilet and any of that crap. Give me a second here. Okay, so how do we do this? How do we get a webcam in the first place in HTML5? Very, very simple. Only requires at least 1 or 2, 3 lines of code. Essentially, what we do is we ask the navigator media devices to get user media. We're going to just pass in video, and we're going to specify default resolution. If you just let it do the default, it'll give you a higher resolution than is needed. So I went ahead and just passed in 50 by 50. Width for height. We basically create an invisible video player on the page, and then we set up another canvas tag, which is used to sample that video. So we can actually extract pixel information from it on a frame per frame basis. Looks like it's slow. That's literally because it's sampling 1 frame per second. I don't want to lag it out too much. So let's carry on here. So working with high resolution images is expensive, right? Especially since we're doing all the processing on the CPU, there's no hardware acceleration here as of yet. We could get into that when we start talking about WebGL. So we're just dealing with 50 by 50 pixels, which essentially results in 500 tiles being used. Any tiles or any pixels that are mapped close to the color black are not rendered at all. That gives us some speed improvements. So like you see around my hands here, those black tiles don't exist. All right. So how do we convert pixels to isometric tiles? Well, let's go look at some of the code here, shall we? Essentially, I already have a tile or a cube image, and I go ahead and preload that. We're going to make some tweaks here to the code so it's easier to see what's happening. So I was applying a scale factor that reduced the scale of the tile significantly, so it's harder to see my point. We're going to go ahead and remove that. we essentially create an invisible image. We load in that image, we move down, we use a create element function in the document to create the video tag. We set the display to none. We want it to autoplay. We add it to the document. Carrying on, we create an other invisible element, in this case, a canvas tag. Canvas tags are very, very cool. It gives you full programmatic access to create essentially images. And if you do those fast enough, if using something like set interval, set timeout, or request animation frame, you can essentially replicate or even create video. So that's kind of what we're doing here. We set the width and height to be equal to the desired resolution, timed tile width, timed tile height for width and height respectively. We absolutely position that. We set the index of -1, so it shows behind the game. We add that to the document body, and since the position is absolute, that means it will display right there. It's not going to be invisible. This is our final canvas. We grab our context, our canvas context. That's where we actually make our drawing operations. And carrying on from that, this is the actual simple call. Right, let's see if this works. It'd be cool if it does. Oh, move down a wee bit. So this draw function, that's cool. That is not what I wanted. See, scroll down, scroll down. All right. So inside that lovely box right there, we do a get user media request. This is a cool API. You could use it to get everything from a webcam to a microphone using just a browser. And of course, you'll get prompted for permission request. But if you set up like something like a PWA, once the user gives permission once, they don't have to give it again. Also, taking it a layer deeper, you can also use it in like Electron to request the desktop, so you can actually do screen share with it. In this case, all we want to do is pass in the width and height, specify the resolution we want, and then the facing mode user just ensures that it uses the front camera of the device. That would be on computer, it'll default to that, or say you have a phone, it defaults to the front camera. Okay, carrying on. Once that device has been requested successfully, I was relying on the fact you have a webcam, obviously I do, then we can actually set up our loop to start processing the image. And there's only 3 functions here that actually compose it. So we basically get the image data from the video, populate it into the hidden canvas. Then we move on to our render isometric. So this is actually what's responsible for taking the video in the hidden canvas frames and then extracting that pixel data and converting it to tiles. I'm going to go ahead and just reload anyway, because I did make some changes to make the tiles bigger. That will have a performance impact, but that's okay. It's for demonstration purposes. So we'll go ahead and invoke that. There we are. So much more blockier effect. You should be able to see clearer that those are offset tiles, not just squares. And with higher resolutions, the effect will be much, much more interesting. Okay, let's get that way and carry on here. So what we do is we basically, every single frame, this is invoked, which is once a second, we clear our canvas. Otherwise, if we don't do that, all the frames would stack up on each other and that'd be quite messy. Then we extract the pixel data from the image data buffer. And then we have 2 nested loops right here that look for the width and the height of the frame. And what we want to extract from that for each pixel is the RGB values, essentially red, green, and blue. And one of the first things we're going to check is to make sure that those RGB values are not black or close to the color black, because that should show it as invisible. Right? So that's what this check is right here. if we want to actually draw a tile, we'll go ahead and pass in our invocation of the draw isometric tile function with the context of the canvas that we want to draw to and the X and Y location of the desired tile plus the RGB values. So red, green, and blue, that's what composes our color here. Moving on to the actual function implementation. You've got to keep in mind that you have to offset what you see from what I see. This is the function right here. We've got some basic math right here to basically simulate a 45-degree angle rotation, taking the square and converting it to something like this. And how we basically achieve that is we take the, it's a really, really bad drawing, but we basically apply some simple maths here to get our iso y. We're going to divide our height by 2, basic operations. Tried to do some optimizations here, didn't go too well, so we won't go too much into that. This essentially will draw our image to the desired X and Y coordinate, which you can see right here. All right, cool. That went all right. So let's read through a more English explanation of that. And then finish this drink though, I don't want to waste it. Bloody day, man. All right, let's pull this back up. Let me switch this over on YouTube as well because I come on so late. It's very difficult to make anything interesting happen. But if you are on here, go ahead and try out the chat. Just type "Hello World." You'll pop up as an avatar. You can actually ask questions or interact with me as I'm explaining some of the stuff that I'm quite excited about. Okay. So we discussed that we needed to do some downscaling. So we want to take the pixels, we want to map it to a isometric tile, right? The frame rate is low. Don't worry, we'll work on that. That'll be the next part. Pull my notes back up. Okay. So instead of just filling the tiles with color, we're actually overlaying an image onto each tile. This means instead of plain rectangles, we get a more textured look. So instead of a pixel grid, like as you see in my video, when I'm circling my fingers right here, I'll do something in isometric space. It's more fun. Now, when I first implemented this, it's obviously ran super slow. Rendering a bunch of tiles in real time is not ideal, especially with the extraction for every single pixel contained in the video frame. So a couple of things that we could do to off the bat to speed that up is just reduce the resolution. Already did that. Off-screen buffering, lower frame rate, boring stuff. That's why we're going to move this into WebGL. I'm not sure we'll get to that tomorrow. I'm supposed to get to bed early because we have a weekend planned, and I have a tendency to be quite an insomniac. So as you can see, based on my stream yesterday, I just hopped on for 14 minutes and basically explained this is what I wanted to do. We got that working. So the next steps, what I'm interested in doing with this? Well, I want to actually apply some physics. I want to get this sped up and I want to increase the resolution. What do I mean by physics? Well, I want to be able to use like my hand to swipe objects in the game in and out the way and stuff. Like this is YouTube controlled right now. It'd be cool if someone's being an arsehole, I could just go ahead and just smack them out of view. We don't have any of that set up yet, but we'll be working on that next. If anyone has any questions, let me know. Otherwise, I will prepare to shut this thing down. All right, guys, appreciate you hopping on with me. A couple of you folks in there, I've seen you tonight. please drop a like or subscribe. Very tiny channel here, and I want to share what I'm working on. I want to share it with someone other than my own mind. All right, guys. Appreciate your time. Have a good one.